Good afternoon, and I'm going to be. I thought about what to present in this talk, and I'm sure everybody knows a lot about security and in everywhere. So I wanted to also include some of our experience and what we are doing, and what is security all about in whatever small way. So I'm using a Mac here, so hopefully I can use it. Basically, I think cloud was always here, as far as I'm concerned. And let's say we keep seeing new incarnations of it. You know, there is a wheel of life. I think like in 1968, Myers and I think Sutherland, they attributed it to first time wheel of incarnation to processes. Every time there was some specific features, we would take it and put it on some dedicated peripheral hardware, and then when it became had more resource and compute, we decided, why do we have these asymmetric processes? Let's put them together. So it's been happening with us, and I think it also happened to us where cloud is concerned. We had different systems. First came Maltus. I think Maltus came in 1964, and it was a project between MIT as well as GE and Bell Labs. And they decided it had a number of features. Among them was availability. And they said the compute will be always available like electricity or telephone systems. And this was the first system which had modular hardware and software. So in that case, you would just, if you needed more resources, you would plug more disk, more CPU, or more memory. And Maltus was also the first system in which was basically designed from scratch with security in mind. And of course, it was broken in a number of times, but still, eventually it got hardened. And the last Maltus, I think, was sold by Honeywell up until 2000. And the security in Maltus is like a precursor or prefigure our security engineering techniques right now. And after that, of course, we had, at the same time, we had mainframes. Again, it was the first, it pioneered the virtualization first time. It ran multiple operating systems on the OSs on the same system. And so it had, again, it was built for, or the big iron was built for high throughput. Then from the mainframe, and mainframe came what we call now client server. Basically, it is, we are trying to run all these processes and some software on we have this plethora or swarm of compute around it. But some people, have you seen it before? Some people say, yes, we have seen it before, it's reincarnated. And Andy, who wrote this article, says it's nothing much like mainframe. You had dumb terminals in mainframe, now you have all these gizmos in your hand where you want to access your data and application all the time. Basically, it was, again, a wheel. Right? We first went from dumb terminals, and then we had this PC at home, and then we realized that we have nowhere to sync it. And then laptop came into being, and other smart devices, smart fridge, smart car, smart everything we have these days. But then we have all these devices, and he says, okay, whereas security is concerned, we are in for a fun ride now. How do we manage security with all these devices and connect with all the number of servers we have in the network? But then some don't believe it. Cloud, is it a mainframe? Seriously, no. This is from VMware, and he says, no, it is not a mainframe, it's something different. And of course, it is similar, but with key differences. Before we meant, okay, we wanted to have redundancy. Mainframe was built on RAS, redundancy, availability, and serviceability. But now we believe not in multi-data center. We don't believe in having as far as we are concerned, having a primary and a failover data center. We are more into n dimensions, n data centers. We want to run our applications horizontally, have them available all the time from n data centers. The second one comes from the n data centers. We want to shard for resiliency. We do not want to shard for geographic availability. And we have a lot of examples in what happened to Netflix and Amazon when their East Coast streaming were degraded in 2009 or something. But we want to shard based on resiliency across the different data centers. Scarcity abundance. Frankly, nobody could have a mainframe in their house. It was too expensive to have a mainframe in their house. So the question was, now we have all this abundance, and where did this abundance come from? It actually from Google and Amazon, right? So when the customer paradigm changed, they went from offline purchases and decision making to online purchases and decision making. Then Google and Amazon had to rush to build all the forms of servers to actually cater to the requirements of the customers or their users. And now we believe in having systems which have built on queue tasks and loosely coupled services. So design in failure mode. Now we work, I think Andrew Stanton, he is the director of Wally. He said we should be wrong as fast as we can. We should just admit it, that we will screw up. We should live with it and work with it. And so N data centers sharded for resiliency is basically based on working or living with failure as an operating mode. In 20th century, we used to say measure twice and cut once. Basically, we used to analyze everything till we were comfortable with it. As Dilbert, the wise man, said to his boss one day, boss said, I believe in management philosophy of measure twice and cut once. He said, but it is inverse in software development. In software development, it's easy to experiment, it's faster to experiment and more cost effective than to analyze and then make a decision about things. Hence came 21st century computer science, in which at Catmull, I think he's the president, he is the president of Disney and Pixar, of their, right. So he said it's better to fix a problem than to analyze it, than to prevent them. What we don't know, we don't know, so we can't prevent. Same way goes for security. We know somewhat from others' experience or from what we read, but most of the time we don't know how we are going to fail. So it's better to fix the problem rather than trying to prevent them all the time. And that's where the new philosophy then comes into being, is in a model of, now we live in a model of DevOps. DevOps was basically as a result of interdependencies between the software engineering, between the operations, and between the quality assurance. Before it was all, waterfallish methodology or maybe agile, but it was not DevOps. In the DevOps model, the developers got to know more they got more control about the infrastructure. So they could get more understanding in infrastructure about the application-centric understanding in the infrastructure. And the DevOps basically Flickr, they adopted, early adopters of DevOps, they wanted to deploy 10 releases of software every day in their data centers, and big companies like maybe Comcast and other companies, we have multifunctional applications, and our deployments are much, the number of deployments in a day are much higher than that, about 10. But this was a result of DevOps. We went from SDLC, Agile, to DevOps. In that, the process was, we went from a process, incremental, and autonomous. So in the autonomous world, we are, the DevOps team is responsible for its operations, its security, its development, and features delivery. Implications of DevOps was deployments became more automated. We could not just deploy in our particular data center, but we can deploy in not only in production, but also in any environments. Automations are, we don't believe in tickets. Telling somebody to do something for us, it's tools. We just automate, we use deployments are automated through tools, and agnostic of infrastructure. There is no source of truth, or you're not locked into a certain infrastructure. You can deploy your systems across different data centers, right? You can do Amazon, Rackspace, or your own data centers. And the best is, in DevOps model, the processes are very well laid out very clearly. Its objective is to maximize efficiency, security and maintenance, and predictability. So once we fail in production, maybe it is because of a DOS on us or an infrastructure failure, meaning hardware failure, we can fail fast. And so in that case, the traffic shaping became the new paradigm of deployment. Instead of we deploying completely, updating our software completely, we would deploy in multi-instances, in multiple data centers or different data centers, and we traffic shape to it. We can discover all the insecurities, or all the security issues, or any functional issues in the data center, or in our releases. We are backward, we deliver in traffic shaping, we should be backward compatible, forward compatible, as well as infrastructure decoupling is very important, because then we can deploy in multiple data centers. Most important is, as I said before, is we work on failure as an operating mode. We know we might fail it. What are the clear directions, and how do we fail back to the normal? And the release management has changed. It is very different now. Trunk-based development, branches for releases. And we do continuous integration in production, and that and a sprint is basically what you ship. It is our unit of release, what we ship in our sprint, and shipping happens all the time. So what I'm trying to point out is that we are very aggressively now releasing in a DevOps model to releasing software, releasing our services, and so we have to take into account how do we best protect our services as well as deliver the features. So basically, we really need to rethink what is our reuse of equivalency principle. Basically, what is our unit of release? It's basically what we release every sprint. It's a effective reuse. So we are releasing a small unit, and we can effectively track it. We can effectively figure out where the problem is. Unit of release. We fail back. It was a small release, we did it, we fell back to the rest of our data centers, or rest of our software where we have the major portion of the customers maybe. So the asset, what I'm trying to say is, asset cannot be just attributed to our data. Think about it from the deployment perspective. For example, what is my unit of deployment, which if can fail, if it doesn't work, I can move over to the another unit of deployment. For example, in one of my teams, we have customer-facing application. In that, there is an application server. It requires some mem caches and requires some static servers. That's my unit of deployment. If I am upgrading, I have a new release coming up, I just go and deploy this unit of and if it works, fine. If it doesn't, it's fine. I can traffic share back to the other units of my deployments. But we need to really think of from the perspective of just not data, but asset applies to deployment also now. This is just to give an example. This is a logical workflow for one of our systems, in which the discovery is one path, and then the video is another path. The playback of the content is another path in which we have a lot of services. We have, we can packages in real time. We can package content into the format that the clients want, a distribution, of course, and then, of course, security, key managers, and license servers. But let's assume this is our logical view of a deployment. Going to multi-data centers, this is a physical view. We have a national data centers, we have regional data centers, but we are not, it provides us elasticity and ubiquity. But see, we have no pods. We are not deploying the whole logical view in every pods. We are deploying based on what are the requirements and how we can easily fail over. For example, if discoverability, if one of the national data centers goes down, we have n number of other data centers, and the discoverability seamlessly can keep working from those, as long as we are not geographically pinned to those data centers. Okay. Now I go to Amazon. So we also deploy in Amazon. Now we not only deploy in our national data center, regional data centers, we also deploy and run our applications out of Amazon. It gives me elasticity. All my traffic cloud bursts or their burst of activity in our systems, we can send the extra traffic off to Amazon. But does it provide me security? People are always worried about if I'm going to be releasing my software or running my software from, which Netflix always does, out of some other third data center, will it be secure? In my mind, it has been always there. For example, consider this. Mainframe, we had dumb terminals. We trusted somebody remotely. There was this mainframe operator. We trusted him or her. We had no other choice but to trust. And this was a remote trust before. And this is almost similar trust when we are deploying our systems in other data centers, or we have our data in other data centers. Now, nothing has, in my mind, has changed in that effect. Consider our own enterprise security. We are very happy. We have a firewall, and our services are inside the firewall, and nobody is going to access them. What about all the people who really have access to those services? Your own administrator, maybe some customers, more employees, more people are getting access to the services. We live in the world of perimeter complacency, that we have a firewall and nothing will happen. But it is true for our own data centers. Our own traditional enterprise deployments. This holds true. So in my mind, if we have to have security considerations where it needs to be in a few ways. We need to provide privacy, as well as we need to, that should not impact the availability. We should not make it so secured, so encrypted that the redundancy, responsiveness of the service, of what we are accessing, it gets deteriorated, right? For availability, we need to keep in mind that we have redundancy, we have responsiveness. In privacy, of course, as we all know, we want access controls and theft of data. For example, from our perspective, if I think about this, is think about redundancy. To be running from multi-data centers anywhere else, I would rather have, from, let's say, about the CAP theorem, right? I would rather have availability and multiple replications, so that when one of my deployments fails, because let's say again somebody attacked it, or it's for some other reason it's not available, I am able to read and write into the other deployments. Maybe it's a deployment of the data store, or it's a deployment of any other services. We should be able to handle availability partitions, Availability can be partial or fully compromised, right? We can have, as I said, we can have events like DOS, we can have natural events, we can have hardware failures, but we need to handle, in multi-data centers, we need to handle no losses, seamless, the organization providing service to their customers seamlessly. Maybe there is eventual consistency to the data. Actually, one of our systems, which we run in cloud, with DVR or scheduler system we run in cloud, it works on Cassandra. It is deployed in multiple data centers. The rings are in multiple data centers. There are units of deployments of services in those multiple data centers. We are not geographically stickiness. If somebody in let's say in some West Coast wanted to do a recording, so maybe some worker on East Coast is going to pick it up and do the job for it. But the question is, we can handle partition intolerance, tolerance basically. If a partition goes down, if let's say on the West Coast or wherever that ring goes down, the work can come through via the services to other data centers. Basically, question is eventual consistency, right? We have to build the software so that it takes care of the eventual consistency. For example, in this mode also, let me give you an example. If a write comes on in some data center and the client who is responsible, let's say a device which needs to record it, goes in and says, okay, you told me I need to do something, give me my data, what I need to do. It might go into a different data center. The data might not have still flown to that Cassandra ring, but you build in the software. You just say, okay, maybe a timestamp or something, and say, okay, I don't have this data, why don't you try again? Next time it connects to a different data center, maybe that already has, or by the time it comes back, this one already has. You don't have such long delays, right? So we need to build our software around in a multi-data data centers in a hybrid world, such that the partitions can be tolerated. And we can eventually have, and that can be easily done by having eventual consistency. Responsiveness, right? First of all, is in macro services. Why do not expose your microservices to all your clients, right? Otherwise, you are increasing the surface area of attack. Your multiple services are exposed. Whatever is needed, why don't you wrap it in a microservice and provide that interface? Your blast radius of effect or attack is reduced to that particular service. And for effectiveness, have persistence from service to server. In one of our systems, we always, when we deploy a new system and when we are traffic shaping to it, the performance is always bad. Because when we have heavy load, the connections are always open, so there is no opening and closing of connections, and we see better performance when we have load on there. So high availability should be always part of the mantra, basically, and real-time metrics. So in our systems, how do we take advantage of the real-time metrics? In one of our systems, we have built in, there's a task queue which comes in, but the thing is, it realizes its health. And if it thinks its health is different parameters, different equations make that health parameter. If it thinks it is not able to take more connections, it rejects them. But it continues to cater to the connections which it already has. Basically, that service has a persistent connections to it from the clients. And in doing so, it goes to other services. And let's say if one whole data center is somehow running very slow because of some network issue or a switch or a router issue, then those services in that data center will start denying the service, and the traffic will automatically flow into the other data centers. The real-time metrics also help. Again, I have a pet peeve of geo-stickiness. People say, okay, the performance will be bad if we don't have geo-stickiness. I think in our mind, in all our systems, we have abstracted that. Abstraction of performance. We should look at the performance as overall and not what happens when you are running, when your data moves. Let's say you have a primary and the secondary one, you have geo-stickiness, and you have in load balancer, okay, when the system is degraded, move all the traffic to the other data center. But suddenly your performances go down, right? Because you now have built all your performance metrics and everything on a geo-sticky system, and now suddenly your system is not performing that well. So in my mind, it's easier, it's better to be always abstract that performance from local connections. Basically, access control. Of course, we all work with, services need authentication. They need authorization. Who is connecting, and are they connecting to the right thing? But at the same time, if we work on patterns like we limit the access. We see if this person is, for example, this person is within a campus. We let the user access to all our services. And let's say, for example, I am using my handheld device, and we know it's a handheld device. We limit the access of data or the access of service or the features to the user. If we think some services or some data is needs more secure, why not do it through monitoring? Monitor it and see, use monitoring to figure out who is accessing the data or who is accessing the service. The network itself needs protection. The devices which are used for network protection, why not have analytics in them for their access control? As well as they already have enough information, use the information, insight from them, what users are coming in and what services or data they are accessing it. So what I'm trying to say is build a system of a security business layer. We have enough data, right? A lot of enterprises, a lot of organizations, they gather a lot of data from their network devices based on, for example, for regulatory compliances, maybe for forensic investigation later on, but they have a lot of data. We need to gather this data and figure out identifying trends in the data that for a potential attack or potential security breaches, right? So locate meaningful signals in that data. Not necessarily we have to secure everything, but we can start predicting and looking at our system when we are deploying. Let's say we did a new deploy, we did a new unit of release. You can use this analytic metrics to see potential of any breaches in the software or so forth. So basically, we need to do more of a risk-based approach for extra monitoring, and that's more like having people anti-pipe pattern is right. More like having people to access your data directly, have services with authentication, and then have more of analytics and figure out how you can actually predict what is going to happen. Again, we can't prevent. As Ed said, we cannot prevent. We should gather data and figure out how to fix it. We will not be able to ever figure out all the breaches which will have in the system. But why not predict them, and why not fix them as we predict them, or analyze our systems better? Theft of data, right? We all use encryptions. We use SSL, TLS. In my mind, there is an anti-pattern for encrypting the data itself. Then once you are encrypting the data, And if you are moving the data between different systems, for example, you're using hybrid systems and they have different data stores, or even security levels, it becomes difficult. So multiple standards of encryption everywhere. It's better to encompass your data with a service, and we provide service level encryption. But still, people will not be comfortable. I agree, people will not be comfortable. There might be more sensitive data which they do not want to expose to public. In that case, what do we do? Well, we can keep the data in our local data stores, in our local data centers, and not put it on the public networks. It has to happen in public networks like Amazon. They provide you data stores based on a couple of things. They multi-hosted. You can have your own environment, you can have your own firewall around it, and then there is multi-tenanted, in which data is basically tagged. Whose data it is tagged, and what kind of security they provide from the access of one user using one data to starting using the data or getting suddenly an access to other tags. Well, it depends upon that. So how well their security patterns are. But so keeping this in mind, not everybody, as I said, not everybody will be very, very comfortable in putting their data out there. But I think we should wrap the data with services and provide enough encryption and use SSL or TLS for transport of your data. And I think that is a very good pattern, and so far we have successfully used it. So basically, briefly, the summary of what I've been trying to say is, when we are going to multi-data centers, the network is flat. In our own organizations, we have different level of security, firewalls. We have, at least in the companies have been working for, we have these green zones, blue zones, red zones, different zones. Nobody can access each other's data, but that zone level will not work once we are going to hybrid mode. The network is flatter, and the security needs to be considered more at the service level rather than at the networking level. This will also, considering this, it would be easier and faster for us to deploy, release software. Otherwise, you run into multitude of issues that there is a port which is not open. I need this firewall access. It basically hinders your progress. Security, as I said, we always, yes, we run very fast and we think, well, we need to put a feature out there first. We will think about security later. But I think it is for security considers for scalability purposes, we really need to think about security upfront than rather bolt it on later. And the bolting on later comes or doesn't come, it comes in a hurry when we realize there is a security breach somewhere. And again, data security, as I said, and service security, they basically are not the same things. And again, I would reiterate my what I said before is we need to think about atomicity of our services and their deployments, and the security surface which we expose. So for example, we should have flatter networks, secure services, and we should avoid stacks. Stacks lead basically to, sometimes you run into issues of degraded performance, or you run into the issues of that coconut issue, right? Hard shell, it's my stack, I am very happy with it, and nobody will attack it. But we forget about there are all these people who are going to be who are all going to be accessing the data. So I think these were my thoughts. I thought I would like to share with everybody from. These are some of the processes, how we are now deploying our software, how we consider what a data center needs to be, and so far it took some time, right? We had to change the mind of our organization, which worked in an agile manner, but it was still a regular SDLC of releasing the software. It took some time to get us in a mode where we are in a DevOps, we run in a DevOps mode. Each DevOps team is holistically autonomous. They release their software. They are responsible for all the issues in their software, and they are up at 2 o'clock in the night if something is wrong, rather than different teams who did not understand. One team built it, the other team tried to support it, which really did not understand the nuances of that service at all. And the third team tried to test it, who really was not part of the team which were developing it, so had no idea what to test it. And we, frankly speaking, we also went very fast. In some cases, we also thought of security the last. But we are undoing a pattern, and we are now fundamentally thinking whenever we are putting the services or existing services that we are redoing them in such a way that they have built-in security in them. So that's all what I had to say about our experiences and what I think hybrid cloud and private data center security should look like, and how we can actually work with it and identify and make our systems more secure. Yes. Oh, sorry.
So thank you. So what you're saying with DevOps, you've completely eradicated app teams and infrastructure teams, that they're just combined and represented for deployment and building of apps all under DevOps.
So yes, we do have what would I call my IaaS. We have infrastructure support services available to us. Yes, other than that, in our teams, and especially in my group, all our teams are running in a mode where they have their own operations, they have their own QA, and they have their own developers. Each application team might have multiple Scrum teams, but eventually they all run in a DevOps team mode.
I have two more quick questions. So who do you find drives the innovation in the choice of cloud technologies? Is it infrastructure teams that are forcing DevOps to get smarter, or is it DevOps that's forcing infrastructure to get smarter, or is it just a mix?
Actually, it's a mix, right? So, for example, in DevOps team, we don't have expertise of the complete infrastructure, right? So as I said, in DevOps mode, the developers are getting, they're providing infrastructure application-centric understanding. So they are trying to understand from our system, we understand the infrastructure. Now the developers understand the infrastructure, then they can understand how they can deploy the application, and how can they build the application to suffice in that infrastructure, right? So our teams, not only we are working now with a couple of infrastructure our own in-house. We have VMware, we have other data centers which have OpenStack, and then we have Amazon, right? So question is, now we are trying to understand what does it mean to deploy into all these different technologies, right? We are trying to, we have a shim or a JCloud or something which have APIs into these various systems, virtualization systems, so that when we deploy, we are agnostic at that point, the underpinnings know where we are deploying, but overall for anybody, it doesn't need to be an operational guy, anybody can, or example. Anybody can go and deploy it when you abstract the details out.
My last question was, I'm sure you faced a uphill battle in shifting the culture, getting people out of the mindset of conventional deployments and thinking more cloud. What did you do to overcome those hurdles?
It was very tough. In some ways, we are still fighting that battle. Some of us which understood how other companies worked, how Netflix worked, what Amazon had to provide us, it was easily we could mold or change the direction. But there were teams, right? There have been teams which are historically trying to provide us operations, the deployments, and the release management was out of it. There were teams which were trying to provide us quality assurance. Those were the teams, right? So there was quite a pushback. How to mold everybody together. So it was an uphill task. It was not easy. I still have, we still fight that. So one of my pet peeves is, in old times, we were so afraid to change code, right? We tested it for 3 months or a year, and then we put in production, and then we were afraid to touch it. It happened in Comcast also. The level of deployments is nothing to do with the people or anything else. This was just the processes we followed. Some of our deployments, or if we were upgrading firmware, at that time the software was with firmware. It was in the boxes itself. It took maybe a year or two to do a release, right? In this mode, we are now releasing. In my teams, we are releasing every week. Of course, if we goof up, we are releasing hot patches every day. But there is some release of each and every service going on in my team, and so we really we had this thing called moratoriums. If somebody sneezes, we have a moratorium. If so out there we have something is happening, we have a moratorium. Don't change anything. We don't want any chaos in our world. It has been an uphill task for me to say, no, please be comfortable with it. See, we deploy the code every day. It is fine. We have built-in unit tests, automation, and everything else. We are changing, and we are not changing the software all of a sudden for everybody. We are traffic shaping. Even the traffic shaping part took some time for people to analyze it. I can traffic shape to 20 people. And we all can internally see if it is fine, then we can move it to another 200 people, and then maybe 10% and be more brave, and 40 and 100% of the customers. It is an ongoing battle, and we have to change the mainframe, and we have some leaders which are making a lot of effort to make these changes. Okay. All right, thank you.